Okay, continuing on the same level of deterioration rates, let's talk about the various ways that the software can determine future NBI values. At later points in the configuration process, we'll set some triggers for actions based on the NBI values. There are two ways to determine those future NBI values. The first is based on the time in a condition state. We call that NBI deterioration, that's what's shown here, or converting the deteriorated elements to an approximate NBI value. That's NBI conversion, which we'll discuss in a minute. Here, we can set a time in NBI state. The optimizer can use your inspection history to determine about how long a bridge deck has been in NBI 5, let's say, and then based on that and the values you've given here, when it reaches, say, 14 years in condition state 5, then it will predict that it drops to condition state, or an NBI of 4. And therefore it will make a guess as to how long it's going to stay in that condition state from the information that you have. If you don't use element inspections, let's say like on your local bridges, then you'll only be able to use NBI deterioration in BRM. And if you only have, say, 10 years of inspection stored in BRM, then the software will not be able to determine that a deck has had an NBI of 6 for 15 years. So your ability to model the future is dependent on the information that you have available. Also note that you have an NBI deterioration curve for each NBI value: deck, super, sub, and culvert. Now down at the bottom of the page, you can filter it out like a subset of bridges and see about how many of these bridges would be good, fair, or poor based on the values that you've set above. This should help you to calibrate these settings, and you'll be able to notice, hopefully, if any of them stand out as giving you results that you would not expect. Now let's talk about the NBI conversion profiles. I mentioned this a minute ago. The other way to generate future NBI values is to convert them from the element values as they deteriorate. And this is done using these NBI conversion profiles. The same profiles are used to recommend NBI values on the element inspection data in the condition page, which we mentioned a few videos ago. The values in the cells are the upper limits for the condition state values. So, for example, if your deck element has 21% in condition state 2, and here you'll see that condition state 2, the limit is 20 is the maximum allowable for an NBI of 7. So 21% would get you an NBI of 6. If you have 21% in condition state 3, then an NBI of 4 is the highest that you can get. We've also included the FHWA profile. In our experience, it's very aggressive because it has no tolerance for anything in condition state 4. But within 2 or 3 years of element deterioration on a new beam, there is 0.001% of the quantity of the deck in condition state 4, and that forces the NBI value to a 4. So it's quite aggressive, which is why the BRM default differs from the FHWA profile. And then, as with the other page, there is a good, fair, poor guide at the bottom to help you find the appropriate setting for your agency. During testing, we came across some states that allow 100% in condition state 3 and say that has an NBI, that's equivalent to an NBI of 5, and some which only tolerated 10% in condition state 3 before considering it an NBI of 4. So these limits will really need to be configured to your agency's practices.